Okay, our next speaker is a gentleman by the name of Mark Hanna from Dawson-Macdonald. Mark began his career at Empire Abrasive Equipment Company in 1983, working in product development. His team developed the MH3, whatever the hell that is, blast gun, and the first direct pressure blasting fan nozzle. Later, Mark established Empire's successful custom cabinets division, which modifies equipment to meet customer-specific work pieces or processes. In 1993, he joined Dawson-Macdonald, which is recognized throughout the Northeast for blasting expertise. Mark has published articles in the Metal Finishing Guidebook and for the Society of Manufacturing Engineers, among others. He also writes the BlastPrep.com blog dedicated to informing industry about the best practices for blast processes of all descriptions. Ladies and gentlemen, please welcome Mr. Mark Hanna.
Thanks, Mark.
You're welcome, Mark.
Thank you. I'm honored to be here at the Surface Finishing Conference. I have a lot of ground to cover, so I'm happy to take questions later on, and I've got to stick to the script. So I spend a lot of time with surface prep workers. Generally speaking, BlastPrep has problems. The situation is not good. Sometimes it is not safe, with slippery bead on the floor, dust hanging in the air, machines that sorely lack maintenance. Blasting isn't as productive as it should be. It's slow going. There's a lot of waste. BlastPrep quality often isn't consistent. And to top it off, the way many of us blast is much more costly than it needs to be. Some workers actually refer to their blasting operation as the pit. Yeah, it can be that bad. I hope yours isn't the pits, but regardless, we all seek continuous improvement. The good news is that fixing blasting can be very easy. You'll make it cleaner and healthier for workers, easier to maintain, more consistent with better results, and obtained faster. By the end of my 25 minutes, I hope I'll have dispelled some blasting myths and have increased your awareness, whether you have a cheap blast cabinet or a room full of automated blasters. There are better ways to blast. It's not rocket science. Start small. Low-cost fixes, small upgrades, training, and changes in attitude are simple steps that can pay off quickly. But don't rule out giving your operation a good hard look, and that takes due diligence, such as committing to try new methods, alternative media, and perhaps a capital investment. Change is hard, but rewarding. So what is BlastPrep? It's a very effective way to clean a surface. It'll blend out imperfections, strip away a coating, prepare a substrate by etching, where you actually increase the surface area by hammering in valleys and raising peaks, making a mechanical interlink for the coating to lock into. BlastPrep is a fundamental manufacturing process, and it's important because you know what they say, the coating you apply is only as good as the surface prep underneath. So let's blast better. When I say blasting, you'll think of the method most familiar to you. But there's more to it. For instance, here's a blast nozzle, and it's ergonomic. And here's another. This is a fan nozzle. It develops a wide fan shape. And here's another one still. This one is the size of a mechanical pencil, and it's used for detail work. So all these users think of sandblasting in different ways depending on what they're using. Now, one key to blasting success is selecting the right media. I know there are specifications you often have to meet. But if you investigate, sometimes you'll find that specs are more tolerant to change than you might think. And you have some freedom to make improvements to the process that will benefit you, your workers, the customer, and your bottom line. Keep in mind that there are dozens of types of blast media in many sizes and in many hardness ranges. It's important. Don't get stuck on one. So here's a round media. These are ceramic beads. They work like the back end of a ball-peen hammer. Hard, round media pulverizes brittle scale, breaking it free to improve surface purity before plating. They can dimple a softer surface, but beads won't affect dimensions much, if at all. And then you have grit. It might be aluminum oxide, steel grit, etc. These particles work like chisels to erode the surface. When blasted, the surface resembles the mirror image of the grit. Coarse grit leaves a high profile, and fine grit leaves a very fine profile. All this depends on the material the workpiece is made of and its hardness relative to the medium. So, uncontrolled, blast results degrade quickly. Let me show you what happens to working media. Consider a glass sphere, but tiny, impacting at high velocity over and over again. After a few cycles, it shatters. You start with a dimpled finish. Remember, the bead starts as a BB shape, obviously. Then the media breaks into sharp shards that progressively get finer and finer, eventually turning to dust. That's no way to keep a consistent finish and quality. So you want to manage your working mix. Your goal is a dust-free, consistent media for repeatable results. You want to achieve a stable working mix, we call it, with the range of grit sizes being thrown at the surface doesn't degrade over time, lest the finish change from part to part and batch to batch, of course. How? Well, there are 3 steps. You got operations, you've got a possible media upgrade, and third, you want to use the right equipment. Here's how I'll cover that, starting with operations. One way to control the working mix is by continually adding small amounts of new media as the dust you're generating is getting scalped off to the dust collector. On the other hand, if you wait for hours and realize, oh no, that you're running low, then add a large infusion of new media, the working mix that has become progressively finer and finer all this time, all of a sudden is much coarser. And that's no way to keep consistent blast results. So make up often in small amounts and keep the storage hopper topped off. That's very important. I find most operations don't do that. So secondly, consider a media upgrade. A more durable media will save on consumption. It'll cost you more per pound, of course, but in the end, it'll save money. For instance, ceramic bead can last 10 to 20 times longer than glass bead. And if you blast at high pressure, the ratio is even greater. And ceramic bead wears down like an onion peels, layer by layer, remaining round. So you continue to impact the surface with spheres and not jagged pieces. There are many other benefits too. There's less trucking of media and less disposal of dust. If you're blasting a hazardous material off the surface, your disposal costs should plummet. I work with a company in New Hampshire. They switched from glass bead to ceramic bead after we did a lot of testing at the demo lab. And they found after a year that they saved $10,000 in disposal costs because they just weren't throwing out hardly anything to the hazardous waste landfill. You can upgrade to a more durable grit as well as a more durable bead as well. So third, you want to be sure you're using the right equipment for production work, and that often isn't the case. Basic machines have their place, but you should consider upgrading your equipment too, and I'll explain. This is a basic machine configuration. You'll see here you have the dust collector that is connected by a 2.5-inch hose to the blast cabinet. Its connection is up in the upper right-hand corner. You're blasting inside the blast cabinet, and that upper right-hand corner is getting great ventilation. Dust is getting pulled out of there, no problem. But throughout the whole rest of the blast cabinet, the dust is just settling down by gravity. It's getting into the working mix. That's going back to the blast gun. You're redepositing dust, and you can't see what you're doing very well. You've seen it before. There's a better way. This is a blast cabinet with a reclaimer, which handles 100% of the media after every impact. And you can see that in this case, the media and the dust that's being generated and whatever coatings are coming off the part, they, again, fall down to the bottom of the blast cabinet, but they're sucked up through a large hose into a cyclonic reclaimer. And the way that works is it extracts the dust through the center pipe, which goes off to the dust collector where it belongs, leaving good-sized media particles that fall down through a scalloping screen where the trash is taken off. And so the good media is deposited into its storage hopper. You can see it's connected by the blast gun hose right back to the blast gun. And the result is that you get extremely consistent, right-sized, dust-free media to the nozzle every time. And here's a new tunable reclaimer that we retrofit onto a crude, older blast cabinet. This blast cabinet is probably about 40 years old, but it still works fine. There's no holes in it. Why throw it out? So I want to switch gears a little bit. I want to talk about the types of blasting. So getting back to where the rubber hits the road, or in our case, where the media hits the workpiece, we usually propel media with compressed air, like with this blast cabinet. But we can also use high-speed mechanical wheels. And you can see what that does. It throws a huge blast pattern and literally tons of media an hour at the workpiece. They're always automated. We can blast with slurry using abrasive mixed with water. I'm going to get into detail on that in a minute. And we can even strip with lasers, where in that case there's no media and extremely little waste to dispose of in the end. However, lasers right now are very expensive, but they're probably going to be the wave of the future. But most of us use a manual blast cabinet. Now, Greg from Chemtol, he mentioned dry ice blasting for non-destructive test cleaning. And that's actually a good application considering the limitations that he also mentioned. So we also have walk-in blast rooms, and here's an example. The operator is suited, he's wearing a type CE air-fed blasting respirator, and that's required. He's wearing leather gloves, work boots, and a blast suit. Our OSHA speaker, Rich Bianchi, he'll like that. It all comes down to PPE. Perhaps the least understood surface prep technique is wet blasting. So I'm going to spend a minute on that. That is, it's water mixed with a concentration of up to 40% abrasive, and that's being pumped to the blast gun. Wet has significant advantages over dry blasting. You eliminate all dust and the static electric shocks that dry blast workers sometimes experience. You also combine a wash step with a BlastPrep. Our friends at Wet Technologies have proven that bonding strength can be tripled using this process. It isn't that important for the people at this conference. Here you can see the water break form on the part, even before the part leaves the blast cabinet. I call that inspection on the fly, and it's a huge boost to timely production whenever you can do that. Wet blasting consumes a lot less media. One user has produced millions of parts in a multi-gun wet machine using less than 2 skids of ceramic bead over many years. So the cost savings is built into wet blasting. We put dust-free wet machines in work cells in factories so that parts don't have to be routed all around the shop. That's a huge gain. Can't do that with dry blasting. It's just too dusty. Wet blasting doesn't fit every application, but where it does, it can be a real process enhancement. So let's say that you've got that new contract and blasting is a bottleneck. We want to ramp it up. How do you do that? Well, there are 2 ways come to mind. One is you can automate, or 2, you can just blast better manually. With automation, obviously you speed up production, you reduce labor, especially tedious work. Who wants to do that? You gain process consistency. That's key. With automation, you lock in blasting's variables. Here's a simple basket blaster at one of our members' shops. But we also have work cell-based automatics like these two for parts large and small. Rotary head blasters that use 9 guns in whirlybird fashion. And robotic blast systems that are truly fantastic. In these robotic systems, they can be dry blast or they can be wet blast. And these this representation it just scratches the surface of the possibilities for automating blasting. But my friends, you don't need to automate to get high production. In fact, there are many jobs where the eye-hand relationship is the only way to go. You can ramp it up with manual blasting, either suction blast or direct pressure blast. So let's talk about that for a second. Suction blasting, I'm pretty sure you're familiar with it, and the attributes that are listed on the slide. If you have a blast gun with 2 hoses, yours is a suction gun, and here's how it works. You have an air jet that forces compressed air over an orifice right above the blast hose. What that does is it creates a vacuum, and it siphons the abrasive, vacuums it up from the storage hopper, up in front of the air jet where it gets atomized, and then it gets blown out through the nozzle. And the important thing is you have about that far to accelerate the abrasive. Now, here's a riddle, and I'll get into that, the difference on that, why that's important in just a minute. Now, here's a riddle. Ever wonder why cheap suction blast cabinets show so little wear? Well, they're blast guns, besides being a little bit old tech, they're built and designed to run off of small air compressors that you'll find in perhaps an automotive shop where these machines are marketed to mainly. But these machines, I see them all over the place in factories as well. But as a result, you have little firepower with these cheap blast guns. So, let's say you have a shop with plenty of compressed air. Why not use it to your advantage and put in a more powerful blast gun in one that's meant for high production? By all means, go with an ergonomic gun like this or one from the manufacturer that has more kick to it. The name of the game is to blast fast. Other favorite of mine is the MH3 that helped develop with Empire many years ago. It's meant for automation. It's always fixtured. It's very easy to maintain. It's very has a nice longevity to it, and it is pretty powerful. So on these next slides, what I'm showing you is a fixture that holds the blast gun for you. So it acts much more like a kitchen faucet. We can take smaller, lighter parts and run them underneath the stream of abrasive spray. It's much more ergonomic. Holding a blast gun all day long is extremely fatiguing. So we were speaking with the OSHA speaker was talking about ergonomics. This is great. It's a nice upgrade. We also have on the right the wide spray nozzle, and that can be fit onto many different blast guns out there in the market. Now that we talked about suction blasting, let's talk about direct pressure. Excuse me. Let's talk about direct pressure blasting. Now with direct pressure, you have a pressure vessel filled with abrasive, and it feeds through a metering orifice of many different styles into the beginning of the blast hose. That's key because you have the length of the blast hose for that media particle to get up to basically the same velocity as the compressed air as it's rushing out towards the nozzle. By the time that particle gets out into the nozzle, it's going the same speed as the compressed air. That velocity is key to getting higher production. The result is that it increases efficiency 3 to 5 times over suction blasting. And we've seen often where you take an 8-hour shift of blasting and you reduce it down to a couple, maybe 3 hours. That's very common using the same amount of compressed air. So, there's a limitation to it. You want to do your due diligence. You want to test it out first on your workpieces. I've seen expensive parts scrapped because operators aren't trained well. These machines work best with a reclaimer. You're going to be making more dust more quickly. You're going to be using the machine many fewer hours a day, but you want to get that dust out of there quickly so it doesn't affect the blast. You will be cracking media quickly. It'll be beneficial in the end. You save a lot of labor. So direct pressure can be more aggressive for tougher applications. If you have a tough coating to take off, you have more control. You have a wide variety of blast nozzles, and I'll show you a couple in the next slides. Now, direct pressure can be retrofit onto some suction blasting cabinets. So again, if you want to save some money, you want to look into that possibility if your old cabinet is up for it. So here's a nozzle for ID blasting. The abrasive comes in from the back, leaves through the side of the nozzle, and that way the angle of impingement on the part is what it should be. This one is at 45 degrees. We can go 90 degrees. We can even go reverse angle. And these come with either one orifice, two orifices, three orifices, or four orifices. They start to use a lot of compressed air with the multiple orifice. Then we have what's known as the banana nozzle. And these can get around corners into the inside of parts. And we can use these in blast cabinets, and I've used these with turbocharger parts, castings, to get around the corners you just can't see. So, thanks. That's part one, I guess. We'll talk to you soon. Thank you.